Welcome back to All This Math. This is Professor Parker, and please hit the like button if you're here. If you're here, go ahead and hit the like button. Also, subscribe to the channel if you're not subscribed already. And if you have any questions about anything I discuss in this video, please put your questions and or your comments in the comment section. And please share this video with at least one other person. Share this video with at least one other person. All right, and tell them to subscribe also. Now, I also want to give a shout out to the sisters that are on my t-shirt. Harriet Tubman, Asada Shakur, Fannie Lou Hamer, and Ida B. Wells. Of course, three of them are ancestors, and Asada Shakur is still present, right? Here's a picture of Asada Shakur, an old picture from many years ago. All right. Please do your research on these sisters, right? Even if you've heard their names before, do some more deeper research. Or if you have already researched them, go reread some things, right? It's never a bad time for a reread. All right. So that being said, let's talk about adding and subtracting fractions. All right. Now these problems are not as difficult as some of the other ones where our denominators are different, because if our denominators are different, we have to find what's called a common denominator. Common denominator. In these problems, we're already given a common denominator. We have 3/5 plus 1/5 in our first example. And in our second example, we have 10/11 minus 13/11. So I got an example of addition and I got an example of subtraction. So basically, let's talk about what these fractions really mean, like conceptually. What do they represent? What does 3/5 even mean, right? I want to make sure you understand that. 3/5 means this. Let's imagine you have an object, some type of object, right? Let's just say a cake. All right, let's say a cake. All right, we got a cake. We divide the cake up into 5 slices, 5 equal sized pieces, right? And then 3/5, what does the 3 mean, right? So the 5 means we divide the cake up into 5 equal pieces, same size, right? And no size bigger than any other size. They're all the same size. And the numerator is 3. So that means we focus on 3 of those slices. Whether we take 3 slices or whether you and your friends eat 3 slices or whether you want to save 3 slices for later, that's what the 3 means. So that's 3/5. That's what 3/5 means, right? And that's also why we don't say 3/5. We say 3/5. How many fifths do we have? We have 3 of them. Always ask the question. Your denominator tells you how many of something, a denomination you have. How many fifths do you have? The numerator tells you that. You got 3 of them. What does this mean? 1/5. Let's say we got another cake. We divide that one up into 5 equal pieces. And in this particular cake, we only want 1 slice. So we focused on 1. That's 1/5. All right. So we take the 3/5 from one cake. Now, also another thing you got to keep in mind is, in order for us to do this addition, another thing that's important is that the sizes of the cakes have to be the same, right? The sizes of the cakes must be the same, because that's another thing. We can't add 3/5 of one size to 1/5 of a totally different size, right? We can't do that. So the sizes must be the same. A lot of times people take that for granted, but that's an important detail. So 3/5 plus 1/5 altogether is how many fifths? How many fifths? 4 of them. 4/5. Now, another thing I want to talk about. So the answer is 4/5, right? But another thing I want to spend some time talking about is, how come the answer ain't 4/10? How come it's not 4/10? I want you to think about that. How come it's not 4/10? Because a lot of students will say, well, I'm adding 3 plus 1. Why don't I just add 5 plus 5? Because you have to understand like what I just explained, the definition of a fraction, the concept of a fraction. What does it mean? The 5 just means that we're dealing in fifths. That's what that means. We just want to know how many fifths there are. How many fifths, right? Not how many tenths there are. If there was a 10 down here, that would mean we was dealing with tenths. But because we took the cake and cut it up into 5 equal slices, we're dealing with fifths. The fifths is our denomination or our denominator, right? It's kind of like with money. If you had $3 and you wanted to add that to $1, you would have $4. Dollars is like your denominator. The word dollars is like your denominator, right? You wouldn't say I have $4 as if you're going to add the word dollars to the word dollars, right? Add the word dollars from $3 to the word dollars from $1. You wouldn't say you had $4. So if that doesn't make sense, then why would you add 5 and 5 and make that a 10, right? We're not adding the denominator, right? We want to know how many of the denominator we have. So we don't need to add the denominator. This means you're being asked, if you have 3/5 and you have 1/5, how many fifths do you have altogether? So that means there's no room. You're not being asked to add 5 plus 5, right? Because we want to know how many fifths you got all together. So that's why we only add the numerators. We only add the numerators. Now, if we're doing multiplication or division, that's something different. You multiply the denominators or you divide the denominators sometimes, right? But when we have addition and subtraction, we're only adding or subtracting the numerators. We only adding or subtracting the numerators, right? And I want you to understand why, because so many students will go ahead and add the denominators because they really don't understand the concept. So I hope from my explanation, this lengthy explanation, that you'll understand not only that it's a rule, because a lot of students, they learn the rule and just don't do it, right? They learn the rule and say, all right, well, I'm just not going to add the denominators, but they still don't know why, right? And they can't explain why. They just say, well, because my teacher told me not to do it. And that's not good enough, right? That's not good enough because we should know. And as teachers, if you're a teacher watching this, you should be able to explain this to your students. Like, yo, why don't you add 5 plus 5? Right? That shows true understanding. That's real understanding. If a 4th grade, 3rd grade student and y'all adding and subtracting fractions, y'all find the least common denominators and all that. And if they can actually tell you intelligently and in their own words, in their own language, their own vernacular or whatever, why we don't add the 5 and the 5, that means they really understand. And that's what we want. We want understanding, right? They should be able to explain that. Let's look at the number 2 with the subtraction. I got 10 11ths minus, whoa. My intention was not to deal with negative numbers. So what I did was I wrote the 13 second and the 10 first. So let's switch that around. So we're going to put the third. Hold up, man. No, I know what happened. Yeah, the 10 was right. But this was not supposed to be a 13. It was supposed to be a 3. Now I remember. Yeah, that was supposed to be a 3. All right, so I got 10 11ths minus 3 11ths, or take away 3 11ths. So what does that mean? Take a cake, right? Divide it up into 11 equal slices, 11 equal size slices. And we worried about 10 of them. We focused on 10 of them. Maybe me and my friends, we eat 10 of them. Me and my family, we eat 10 of them slices, right? And then it's another cake, right? Same size cake, divided up into 11 slices. And we might eat 3 of those slices. And let's say the question was, well, how many more slices did we eat from the first cake than the second cake? That's a subtraction problem. That's a little basic subtraction word problem. So 10 11ths minus 3 11ths, right? How many 11ths am I left with? How many 11ths do I have? That's why we're not going to do 11 minus 11. We're not going to do 11 minus 11 because we want to know how many 11ths we have. So we don't mess with the 11ths, right? The 11ths are like a unit of measurement, like a dollar, like an inch, like a degree for temperature, right? Right? So if it was like 85 degrees yesterday and it was 75 degrees today, and you wanted to know the difference in temperature, right? You would do 85 minus 75. You wouldn't do degrees minus degrees, and then the word degrees is gone, right? So think about that. Your denominator is like a unit of measurement. Matter of fact, write that down because that's going to help you remember. The denominator is like the unit of measurement. You don't mess with the unit of measurement. It's like dollars, like I talked about earlier with number 1. It's like currency. Like if we're dealing with dollars, if I had $10 and I spent $3, I do 10 minus 3 and I get 7. I'm left with 7. I'm not doing the word dollars minus the word dollars and then, okay, the word dollars are gone because they canceled out and I just got 7. No, you still got $7. The word dollars is still there. So a denominator is like a unit of measurement. That's why we didn't do 5 plus 5 to get 10 up here. And we're not doing 11 minus 11 to get 0 for our denominator down here. You do not subtract denominators. You do not add denominators. Right? But I want you to, like I said, a lot of students just memorize that rule and they don't really understand why and they can't explain why. I want anybody watching this video to be able to explain why. Like, why don't you subtract 11 minus 11? Because the denominator is a unit of measurement, right? The unit of measurement is meant to describe what we're dealing with. We're dealing with 11ths. So we had 10 of them and we subtracted 3 of them. How many are left? 7 of them. And parents, if you got elementary school age children, I want you to understand this so you can have that conversation with your kids, right? You should be their first teacher. You should be the one they should be able to come to when they need math help. And we got to stop talking about all this like new math stuff. And I don't know how to do this. If you don't know how to do it, that just means you got to put some work in and go learn it. And we can't just be like, yo, I already graduated elementary school. I was in elementary school 20 years ago, 30 years ago, 40 years ago. I don't got time for all that. You got to make time. It's part of your responsibility as a parent. I mean, what you want your kids to fail in math? We got to make time. We got to make the time. And I'm here trying to make it easy for you, right? Because I know how to explain this, right? So I'm trying to make it easy for you, right? I know we busy. We got multiple jobs. We got lives. We got, a lot of responsibilities. I get it. That's why I'm doing what I'm doing. Because I'm trying to make it as palatable as possible. All right. So parents, we got to understand why you don't do 11 minus 11 and why you don't do 5 plus 5. Because you need to be able to explain it to your children, your grandchildren, your nieces, your nephews, right? You the favorite uncle, you the favorite aunt. Explain to them some math. Explain to them why you don't add denominators. Explain to them, be the favorite aunt, be the favorite uncle. Explain to them why you don't subtract denominators. Go ahead. We got to start doing that as a community. Because at the end of the day, when the children do poorly on these standardized tests, or they not doing well in their math classes, what happens? Everybody mad. Everybody got something to say. Everybody upset, right? We could prevent that. We could do something about that proactively, right? We just got to put the work in. So I wanted to do this video because I really just wanted to talk about why we don't do 5 plus 5, why we don't add denominators, and why we don't subtract denominators. I hope that we understand. Again, it's just like the denominator is a unit of measurement. The denominator is a unit of measurement. That's what the denominator is. It's a unit of measurement, right? Just like dollars is a unit of measurement. You don't subtract or add the word dollars when you're adding or subtracting different amounts of money, right? When we're adding or subtracting the temperature, we don't add or subtract the word degrees, right? If we're talking about measurements, we don't add or subtract the word inches or the word millimeters or the word centimeters or feet or yards or miles. We just keep it. We keep it and we say it one time, right? It's a unit of measurement. That's what a denominator is. You can think of a denominator like that, a unit of measurement, right? How many elevenths do we have? How many elevenths are we left with after we subtract? How many fifths are we left with when we put this many fifths with that many fifths, right? So yeah. So if any of this didn't make sense, then you know what I'm saying, just rewind the video or put your specific question in the comments. Go ahead, put your specific question in the comments. Go ahead, type it up. All right. And I might make a follow-up video, to address your specific question. But in the meantime, like I said, research these sisters. Make sure you're familiar with Ida B. Wells, Fannie Lou Hamer, Asada Shakur, Harriet Tubman. Make sure you're familiar with them. You know what I mean? And get some practice adding and subtracting fractions. All right. Adding and subtracting fractions. All right. Same denominators, common denominators. All right. I'll see y'all in the next video.